Simcenter 3D can help automakers achieve quieter, smoother vehicles using simulation for noise, vibration, and harshness, otherwise referred to as NVH. In this demonstration, the concern is about noise generated by an air intake manifold. Such manifolds come in all sizes and shapes and are a key component for engines to make sure air is flowing smoothly into the combustion chambers. The components are not actually stressed, but they generate very high interior noise from the engine that causes the manifold to vibrate and radiate noise. Simcenter 3D is an ideal tool to study and improve acoustic performance of manifolds and improve the car's end customer experience. Simcenter 3D makes geometry editing for CAE easy. In this model, you first need to simplify the geometry and remove some holes that have no bearing on the acoustic simulation. This is simply and quickly achieved using direct editing through Siemens synchronous technology, where geometric features can be removed with no knowledge of how the part was built, nor is any specific CAD expertise required. Next, because you're performing an acoustic analysis, it's necessary to generate the interior and exterior acoustic enclosures for this manifold. What would otherwise be a time-consuming task is completed in minutes thanks to the powerful geometry engine that is core to Simcenter 3D. To create the interior air domain, you proceed by extracting a copy of the part and select the interfaces to delete. Because the faces are tangent continuous, they're all selected, but by quickly selecting the opposite surfaces, Simcenter 3D knows to remove the outer surfaces and generate the internal cavity. Similarly, an exterior volume can be created by generating a simple volume from which you will subtract the manifold and a newly generated internal volume. Now that the acoustic volumes have been generated, you can create the corresponding meshes. Here again, one of the unique capabilities of Simcenter 3D is a unified and integrated environment where you can immediately mesh the components. First you mesh the manifold, then you mesh the acoustic volumes. Again, a powerful capability with Simcenter 3D is the ability to create multidisciplinary models where you can have a structural mesh and an acoustic mesh generated at the same time. NX-Nastran as the acoustic solver can automatically work with otherwise incompatible meshes. Because we have selected a vibroacoustic solution, Simcenter 3D intelligently provides the right element types. For example, note that you can select an acoustic fluid type tetrahedral mesh for the acoustic bodies. Lastly, you need to define a mesh that will represent the microphone surface above the manifold. Once these meshes are defined, they can be assigned their material properties and you can add the loads and boundary conditions. You now define a vibroacoustic simulation, and it should be noted that the pre- and post-processor interface is the same user interface whether you're doing a structural, acoustic, vibroacoustic, or even a thermal analysis. This ensures a consistent user interface and makes it easy to efficiently run solutions for modes, vibration response, or acoustic response analyses. In this simulation, you want to evaluate the acoustic performance of this air intake manifold. In doing so, you need to define some forcing frequencies from 100 to 1000 Hz. And to speed acoustic solution time even more, Simcenter 3D has the ability to define an automatically matched layer, or AML. The AML is similar to a perfectly matched layer, or PML, that is used for acoustic simulation. However, you don't need to physically model the AML unlike you do for a PML used in other tools. This means the AML, which is only available in Simcenter 3D, reduces both your modeling time and even solving time, since the FE Acoustics models are smaller. Structural fixed constraints are applied at each of the manifold ports, where again both structural and acoustic loads and boundary conditions are generated at the same time. Finally, an enforced motion load is applied to the inlet to simulate the pulsating noise from the engine. This model is ready to be solved, and once it's completed, you can view the results. In this case, you're interested in looking at the acoustic pressure. Simcenter 3D allows you to define post-processing templates that can ensure a consistent and quick representation of the results. In this case, by applying an acoustic pressure template, you can see the acoustic waves propagating from the structure. You can then overlay the deformation results for the structure and see how the structure deforms along with the acoustic waves. Note that we see the highest pulsating displacements on the top surface of the manifold. Further investigating the model, you can plot the acoustic power results and the frequency response to the driving frequencies previously defined from 100 to 1000 Hz. Simcenter 3D offers a number of post-processing tools to further probe your results, and in this case, you can quickly probe the peaks of the curve and highlight the magnitudes of interest. Based on these results, you seek to minimize the radiated noise. One way of reducing the noise is to stiffen the structure, and you might decide to thicken the upper panel of the manifold. One of the strengths of Simcenter 3D is that the analysis model is associated to the underlying geometry. This means you can quickly modify the geometry to test out a new design proposal and update the entire analysis model without having to manually rebuild it each time. This is possible on any geometry from any CAD source. What would otherwise be a cumbersome multi-day workflow in other tools is reduced to just minutes in Simcenter 3D. After modifying the geometry, you can then simply update the meshes and verify that this design change has propagated to the mesh. A quick resolve, and you can again look at the acoustic power results, this time comparing the new design to the initial one. Once you overlay the results, you can clearly see that adding thickness to the top of the manifold has reduced the noise in the structure and increased its overall acoustic performance. Adding thickness is undesirable since it adds extra weight to the part, so you might also look at a third design with ribs. Again, it's possible to update the existing analysis model for the new design and compare the acoustic power results. The noise for this design is not necessarily lower over the entire frequency spectrum. Some acoustic peaks are not changing while some structural peaks are shifting. Simcenter 3D can help you quickly go from CAD design to evaluating acoustics performance. Simcenter 3D's analysis model to geometry associativity can help you rapidly explore design alternatives, so your engineering team can deliver timely insights into the automotive design process.